Hello everyone and welcome to another video. Today we'll start topic 6, electrochemistry for IGCSE students in year 10 taking the extended curriculum. We'll start off this topic by comparing between conductors and insulators. Well, conductors are substances that allow the flow of electricity. That's because they either have freely moving electrons or freely moving ions, and these are the two main ways for electrical current to flow, either by electrons or by freely moving ions. For example, all metals and graphite, and if you remember correctly, graphite is a macromolecular form of carbon. They have mobile or freely moving valence electrons. Molten or solutions of ionic compounds, they have freely moving ions. Also note that the solid form of any ionic compound, for example sodium chloride, does not conduct electricity. That's because the valence electrons are used in making the ionic bond, keeping this compound together. So in the solid form, ionic compounds do not conduct electricity. They have to be molten or in a solutions to be in the form of ions. Here we have a simple electric circuit. We have a battery, a power source, and a meter to record the current intensity, a metal to continue conducting electricity, and a bulb. When you close the switch, this bulb will illuminate, but if you replace this metal with an insulator like wood or plastic, for example, the bulb will stop illuminating. Okay, now if we want to compare the electrical conductivity of two metals, there is actually a simple way to do that. We make a simple circuit like that, and this will be metal A right here. Here we have a bulb because we need an indicator of the the intensity of the current flowing, and we close our circuit, right? And we have another circuit, and we have metal B right here. Again, another bulb, and we close our circuit. When you close the switch of the battery and allow the electricity to flow, the metal with better conductivity will give a higher or stronger illumination in the bulb. So that's how you compare the electrical conductivity of two different metals. Okay, now the uses of conductors. We have two examples. We have copper and aluminium. Copper is used in electrical wiring because it's a good conductor of electricity. Of course, it's ductile, so it can be shaped into wires, and it's easily purified, right? It's easier to separate from its impurities than other metals like iron, for example. That's why we use copper instead of iron in making electrical wires. Aluminium is used in making high voltage lines because it's a good conductor of electricity, and it resists corrosion, and it has low density, so it's lightweight, and of course it can be shaped as well. In high voltage cables, there is always a steel core, right? This one right here. This is the steel core. The function of that is to add additional strength to stop these high voltage cables from snagging or breaking, because if you don't have that, it will break due to environmental circumstances. So we add that steel core to add some strength to the whole cable. Let's talk about insulators. Insulators are the opposite of conductors. These are substances that resist the flow of an electric current. Why they resist the flow of electric current? It's because they do not have any mobile electrons, and of course they can't be ionized, so there are no ions, and they have no electrons, or no freely moving electrons. Examples to insulators will be plastics, glass, ceramics, and of course all non-metals except graphite, except for graphite. The uses of insulators, we have two examples, plastics and ceramics. Plastics like PVC or polyvinyl chloride, which is an organic polymer. This is used to cover electric wires to protection, to prevent people from getting shocked by electricity. It's a bad conductor of electricity, so it's used as a protective method. It's flexible and easily molded. It's non-biodegradable, so it's environmental friendly, and it's cheap and can be recycled. Ceramics are made by heating clay. Clay is that substance you find in the bottom of rivers. When you heat that, it solidifies and forms ceramics. It's used in making fuses, base of electric iron, and heaters. If it's used in making the base of electric iron, then it must be heat tolerant. It must be able to endure high temperature, which is actually true. It has a very high melting point, so it can be used at high temperature. And they do not conduct electricity, of course, so they can be used in any of these situations. They are also used in high voltage electricity towers or pylons to keep these wires away from touching each other and touching the ground. They are not affected by water or oxygen of air, and they can be molded to complex shapes. So this was a quick introduction to the topic. Now let's talk about the main thing here, which is electrolysis itself. So electrolysis is the decomposition of an ionic compound when it's molten or in a solution due to the passage of an electric current. So we need to note that our ionic compound must be either molten or as a solution, okay, dissolved in water in an aqueous form. Electrolysis itself is a decomposition reaction, meaning that we break down an ionic compound into its main form, as we will see in a few minutes. Also note that electrolysis is an endothermic reaction, meaning that it requires energy or it requires heat. It absorbs heat from the environment around it. It does not release energy. It's endothermic. And in electrolysis, we have electrical energy being transformed into chemical energy. All right, we'll talk about that in a few minutes. Now, if we're to make a simple electrolytic cell, what do we need? First off, we need a power source. That will be our battery. We will have a wire, two electrodes, one attached to the positive pole of the battery and another one attached to the negative pole of the battery. These are our two electrodes. And we will need an electrolyte. And the electrolyte is our molten or ionic solution that we are electrolyzing, right? Okay. Now to labeling. The electrode connected to the positive pole of the battery is called an anode. Here. The electrode connected to the negative pole of the battery is called a cathode. This is our electrolyte. And this is our battery, right? First thing you need to note is that the electrodes are made of graphite or platinum. Right? These two are inert, meaning that they do not participate in the chemical reaction. All they do is that they conduct or transport the electrons. That's all they do. They do not participate in the chemical reaction in any way. Also note that graphite is a non-metal, while platinum is a metal. Okay, so our electrodes can be made of a non-metal, that would be graphite, or a metal, and that would be platinum. Okay, now let's take an example to this whole electrolysis process. If we are trying to perform electrolysis to lead bromide, molten lead bromide, of course, because as we've agreed, our ionic compound must be either molten or in an aqueous form. So why did not we take lead bromide in an aqueous form? Because it's insoluble. You can't dissolve it in water. All right. The solubility rules, I'll talk about them in topic 7, acids and bases. But for now, just know that lead bromide is an insoluble salt and you have to melt it. Okay, you can't just dissolve it in water. Now, how do we get that molten lead bromide? We use an electric heater, simply because Bunsen burner does not provide enough heat to dissolve lead bromide. It has a very, very high melting point. Alright, so we need a stronger source of heat, like an electric heater. Alright, so what exactly happens in this electrolysis process? Okay, so this is lead bromide. Lead bromide is made of lead ions, 2 positive, and bromide ions, negative. Right? What happens is as follows. You pass an electric current coming from this battery into your electrolyte, which is lead bromide. Alright? Two reactions happen. Two redox reactions or oxidation reduction reactions happen. One at the cathode and another one at the anode. The one that happens at the anode is the oxidation reaction. Remember that oxidation and anode both start with vowels, so that's an easy way to remember it. As for the cathode, that's where the reduction reaction happens. As a reminder, reduction is gaining of electrons, while oxidation is the loss of electrons. Okay, at the anode, the bromide ions lose electrons, 2 electrons, forming bromine gas. This is a loss of electrons, so that's an oxidation reaction. While at the cathode, the lead ions gain 2 electrons, forming a gray solid or a gray deposit of lead. Okay, now if you notice, the amount of lost electrons equals the amount of gained electrons. So if we are to write the full ionic equation for these two reactions, these are called half ionic equations. The reaction happening at the cathode on its own is a half ionic equation, and the reaction happening at the anode is another half ionic equation. Now if we're to write, I don't know where to write that. If we are to write the full ionic equation, just add these two equations together as follows. Here we have lead ions plus, of course, these 2 electrons were gained and lost, so they're not gonna make it to the final equation or the full equation. So we have lead ions plus bromide ions, correct? That gives us solid lead and bromine gas. Right. Of course, there's a missing 2 in here and missing 2 in here, because 2 bromide ions will lose 2 electrons. Each bromide ion will lose 1 electron. 2 bromide ions losing 2 electrons, giving us a bromine gas. So we have lead ions, 2 bromide ions, lead as a solid, and bromine gas. Right. Now to the observations. What can we observe from this reaction? Actually, we can observe 3 things. Number 1, we will have bromine gas, which is a reddish brown gas at the anode. We will also have a gray color or a gray deposit of lead at the cathode. That will be at the cathode here. and that will be at the anode. The third observation is if in this circuit right here we had a bulb, right? This bulb will give out light, so the bulb illuminates. We're gonna have illumination, right? But if the circuit you have did not have a bulb, or the circuit in question did not have a bulb, of course you can't write that third observation, right? So to recap, here's exactly what happens. The ions move in opposite directions. This anode is positively charged, meaning that it will attract the negative ions. These are the bromide ions. So here we have the bromide ions going towards the anode. Right. This cathode right here is negatively charged, so it will be attracting the lead ion, the positively charged lead ions right here. So these will be going this direction. Okay. At the anode, there's an oxidation reaction, meaning that the bromide ions will lose their electrons and they will turn into reddish brown gas of bromine. These electrons will start flowing like that from the positive pole to the negative pole of the battery and enter the cathode, where they will be gained by the lead ions and turn into solid lead, right? Which will eventually fall over the cathode, right? So these are the reactions happening at both the cathode and the anode. So again, in this simple electrolysis cell, we need to know that which one is the anode, which one is the cathode, the reaction happening at the anode, the reaction happening at the cathode, the electrolyte, of course, and the observations. These are the important information you need to take in consideration. Of course, also note that there are precautions that must be taken before conducting such an experiment. This reaction releases, this reaction releases bromine gas. Bromine gas is toxic, so this reaction must be carried out in a fume commode. Another thing is that lead bromide and lead both are toxic, so you must handle them while wearing gloves. So these are the precautions to take before conducting such an experiment. Okay, let's take some more examples. We will have to predict the product at the cathode, the product at the anode, and write the half ionic equations, right? Here we have aluminium oxide, right? So aluminium oxide is made of positive aluminium ions and negative oxygen ions here. Of course, the aluminium ions will be attracted to the cathode, while the oxygen will be attracted to the anode here. At the cathode, we have the reduction reaction, so aluminium ions gaining 3 electrons to form aluminium solid. At the anode, we have the oxidation reaction. We have O2 or oxygen ions losing 2 electrons. You can either write it like that, minus 2 electrons, or add the 2 electrons to the products. Either way is correct. To form oxygen gas. Right. The problem with this reaction is that the number of lost electrons does not equal the number of gained electrons. So what we can do is that we can multiply the cathode reaction by 2. So we'll have 2 aluminium ions, and here 2 multiplied by 3, we will have 6 electrons and 2 aluminium atoms. And multiply the reaction at the anode by 3 so that we can have 6 electrons. So we'll have 3 oxygen ions and 6 electrons and 3 O2 gas molecules. And from that we can write the full ionic equation as follows. 2 aluminium. Of course, the electrons gained were lost. The electrons lost were gained by the aluminium, so they're not going to make it to the final equation. 2 aluminium ions plus 3 oxygen ions and here we have 2 aluminium atoms plus 3 oxygen gas molecules. These will form bubbles at the anode, colorless bubbles at the anode, and we will have the aluminium precipitating on the cathode, right? Of course, there are other examples that you can try for yourself in the notes, but just for the sake of time, we are going to move on from this point. So far, we've talked about electrolysis for molten ionic compounds, right? So these examples, the lead bromide and the Al2O3, the aluminum oxide, the copper bromide, even the sodium chloride, even though sodium chloride is water soluble, you can perform electrolysis to molten sodium chloride, and these will be the results in this exact same manner. Now, what if we have a solution, aqueous solution? What if our electrolyte is water soluble and we have a solution of it? There are some rules that we need to follow, right? But in order to look at these rules, let's just first take an example. We have sodium chloride dissolved in water. Okay? Sodium chloride is made of sodium ions and chloride ions. Right? Water, I know it's a covalent molecule, but in electrolysis, it can actually be converted into 2 separate ions. That would be hydrogen, positive hydrogen ions, and OH, negative or hydroxide ions. Now you might be wondering, we have 2 cations, we have sodium ions and hydrogen ions. Which one of these will be gaining the electrons? And we have chloride ions and hydroxide ions. Both of these can lose electrons. Which one of them will lose the electrons? That takes us to the rules of electrolysis of a solution. Let's take a quick look at the reactivity series. I'll be talking about the cations first, and then we will move to the anions. The reactivity series starts with potassium, sodium, calcium, magnesium, and then we have hydrogen and copper, and so on, right? These are the most important ones that we need to focus on. Now, form the cations or the ions of these elements. We'll have a potassium ion, sodium ion, calcium ion, positive, magnesium ion, hydrogen ion, and copper ion. Okay. As we all know, that potassium is the most reactive of these all. So it has a very high tendency to form an ion. Once it forms that ion, it's very stable, meaning that it does not want to convert back to its atomic form, which means that potassium ion is the most stable or least reactive. Going down the reactivity series, the reactivity of the ions increases, meaning that copper right here is the most reactive ion. We are talking about the ions and not the atoms themselves, right? So if we are to apply this to this example we have here, we have sodium and we have hydrogen. Sodium is up here while hydrogen is down here, which means that hydrogen is more reactive than sodium, meaning that hydrogen is more likely to discharge. Now, what's meant by discharge? Discharge, from its English-wise, this means removal, and charge means removal of the charge, okay? So removal of the charge happens to ions. Either they are cations and turn into atoms, or anions and turn into their corresponding atom. So that's the meaning of discharge. A discharge for a cation happens by gaining electrons, while discharge for anions happens by losing electrons. So again, hydrogen will be more likely to convert to hydrogen atom or hydrogen gas than sodium will be to convert to its atomic form. which means that in this example right here, hydrogen is the one to discharge, right? As for anions, we have the halogens, fluorine, chlorine, bromine, and iodine. And if we are to convert these to their ionic forms, we will have fluoride, chloride, bromide, and iodide, right? Before fluoride, we will have the hydroxide ion, the nitrate, NO3 negative, and the sulfate, SO42 negative. Note that these two, the sulfate and the nitrate, they never, ever discharge, right? So if you have an ionic compound containing sulfate or nitrate, these two will never discharge. The other available anion will discharge, but these two will never do that. So fluoride, or the fluoride ion, is very, very stable, which means that it's very not likely to turn into or convert back into fluorine, while iodide is very reactive. The iodide ion is very reactive, which means that it has a very higher tendency to convert back to iodine, which means that just like for the cations in their activity series going down in this direction, there is a higher tendency for the ions to convert back or discharge. Okay, so to apply that on the example we have here, we have chloride and we have hydroxide, right? Hydroxide is up here, chloride is down there, which means that chloride is more reactive than the hydroxide ion, which means that chloride will be the one to discharge and not hydroxide. So now that we've determined which ions will be discharging, we can write our half-ionic equations and determine the products of this electrolysis reaction. Okay, so we've agreed that hydrogen will be the one to discharge and chloride will be the one to discharge. Okay, at the anode, we have our oxidation reaction. Oxidation is loss of electrons, so chloride will lose an electron, or to be more accurate, two chloride ions will lose 2 electrons, forming chlorine gas. As for the cathode, we have our reduction reaction. 2 hydrogen ions will gain 2 electrons, forming hydrogen gas. This cell, the sodium chloride, or the concentrated sodium chloride cell we've just discussed, it is a very common cell. It works with concentrated sodium chloride because we need enough amount of sodium chloride salt to compete with the hydrogen and the hydroxide ions. And it's also called brine. And the reactions that happen, the solution containing sodium chloride ions from the salt, hydrogen and hydroxide ions from the water, the positive ions, the sodium and the hydrogen, will be attracted to the cathode, while at the anode will have the hydroxide and the chlorine. At the cathode, the hydrogen will be the one to discharge, and we have explained that whole part, since hydrogen is less reactive than sodium. So we have 2 hydrogen atoms gaining 2 electrons, forming hydrogen gas, so hydrogen gas will be bubbling off at the cathode. While at the anode, we will have chlorine getting discharged because it's more reactive. The chloride ion is more reactive than the hydroxide, so 2 chloride ions will lose 2 electrons, forming chlorine gas, which will bubble off at the anode, right? This is a drawing of the cell. Of course, you're not required to draw the cell, but you need to know the labels. Here we have brine, and that's how you insert the concentrated sodium chloride solution. That is the electrode connected to the positive pole of the battery, meaning that this is the anode, while this one is the negative pole, which is the cathode, right here. Okay. Here we have sodium, hydrogen, chloride, hydroxide, and more. water. Right. At the anode, we have agreed on the reaction that will happen, and chlorine gas will be bubbling off in here. And here, at the cathode, we'll have hydrogen gas bubbling off, and of course, it's very normal for sodium and hydrogen, these two, to be attracted to the cathode. But what is hydroxide doing in here? It's very simple, actually. Sodium was attracted to the negatively charged cathode, while the hydroxide was actually attracted to the sodium ions. And that's why the hydroxide ions are in this side right here. They were attracted to the positively charged sodium ions. In between these two half cells, we have the diaphragm, which acts like the cell membrane. It separates the two half cells and allows certain ions to pass while preventing others. Right? The products of this reaction are actually very important in industry. We have chlorine right here. Chlorine gas is actually used in making plastics like polyvinyl chloride, from the name PVC. Polyvinyl chloride has chlorine in it. Solvents for degrazing and dry cleaning, medical drugs, weed killers and pesticides, bleaches, of course, because chlorine is a bleaching agent, paints and dyes, hydrogen chloride and hydrochloric acid. And let me just note that there is a huge difference between these two. This is hydrochloric acid, that's an acid, and that's hydrogen chloride, it's a gas. They have different names and different state symbols. It's also used in making sterilizing agents because it kills bacteria in water. Sodium hydroxide formed due to the interaction between sodium and hydroxide here. We have sodium hydroxide as a byproduct. It's used in making soaps, detergents, viscose or rayon, and other textiles, paper, ceramics, dyes, and medical drugs, and of course extraction of aluminium, as we will see in this exact topic later on. Another important product is also hydrogen gas. Hydrogen gas is used in making nylon and hydrogen peroxide, H2O2, which is a very strong oxidizing agent, to harden vegetable oils to make margarine, and as a fuel in hydrogen fuel cells, and in making ammonia by Haber process, which we'll talk about later. Now let's talk about another cell. That would be the diluted sodium chloride cell, the NaCl, but this one will be diluted, which is very important to know the difference between diluted cell and concentrated cell. Meaning of diluted is that we have excess amount of water. This excess amount of water will mean that we can actually neglect the sodium chloride. Our main ions will be the hydrogen and the hydroxide in this reaction in here. So there will be no competition because the amount of sodium chloride is actually too low compared to the amount of water. In that case, we will be talking about electrolysis of water. Just like the rules we've discussed, hydrogen is positive, or hydrogen ion is positive, so it will be attracted to the negative cathode. Sorry, here. Hydroxide is negative, so it will be attracted to the positive anode. Here we will have the oxidation reaction. Oxidation is loss of electrons, so OH will lose one electron, forming water and oxygen. Okay, of course this equation is not balanced at all, so here we will have 4 electrons and we will have 4 OH ions and 2 water molecules, just to balance the equation. That's liquid and that's gas, of course. At the cathode we have reduction, so 4 hydrogen atoms will gain 4 electrons, forming 2 H2 molecules. Okay, so hydrogen will gain electrons at the cathode, which is reduction, and hydroxide ions will lose electrons, forming water and oxygen, and these are the 4 electrons that were lost. As for the overall reaction, these 4 electrons were lost and gained, sorry, lost here and gained there, so they're not going to make it to the final equation. 4 hydrogen ions plus 4 hydroxide ions form 2H2 gas plus 2H2O, which is liquid, plus O2 gas. Okay, so the electrolysis of water actually forms back water again, which is very useful for using this very cell for spaceships, because that gives astronauts water and fuel due to the electrons that were formed in here. And of course, hydrogen and oxygen both have very important industrial functions. We've talked about hydrogen in making hydrogen peroxide and other things, and oxygen in making oxygen tanks. Okay. An important question in this part is why is the volume of hydrogen double that of oxygen? Simply because water is made of 2 hydrogen atoms and 1 oxygen atom. The molecular formula for water is H2O. So it's 2:1 hydrogen to oxygen respectively. Another important question is that in electrolysis of water we have to add sulfuric acid, H2SO4. Why? Simply because water is a covalent compound. It's a very bad conductor of electricity, while H2SO4 can be dissociated into hydrogen and sulfate. So that provides the ions for the electrical flow. But again, it's a diluted solution, which means that the sulfuric acid will not be competing against the water because there is an excessive amount of water, which means that the final products will also be an electrolysis of water process. So these will be the products. The sulfate will not be competing at all. If we are to take an example where the sulfate will actually be doing something or present in the reaction, that would be copper sulfate, electrolysis of copper sulfate, CuSO4. Actually, this will be a concentrated solution of copper sulfate. So here we have copper sulfate and here we have water as well, because it's a concentrated solution, but we still have water. Here we have copper to positive. It will be just like the sodium chloride example, the brine example, the concentrated sodium chloride. And here we have the sulfate to negative. Here we have hydrogen, and here we have hydroxide ions. Okay, if we remember from the reactivity series, copper is actually below hydrogen in that reactivity series, which means that the copper will be the one to discharge and not the hydrogen. And if we remember as well that the sulfate never discharges. The sulfate and the nitrate, these two never discharge. So the hydroxide will be the one to discharge. The copper ions are positively charged, so they will be attracted to the negative electrode. The negative electrode is the cathode. At the cathode we have reduction, so these are the copper ion gaining 2 electrons and forming solid copper. And these hydroxide ions are negatively charged, opposite charges attract, so it will be attracted to the positive electrode, which is the anode. At the anode we have an oxidation reaction. These are OH negative. It will lose 4 electrons, forming 2 water molecules and oxygen. Right. Okay. Again, the amount of lost electrons does not equal the amount of gained electrons. So we will have to multiply here by 2. We'll have 2 copper, and this will be 4. And here we have 2 copper atoms. The overall reaction will be 2 copper ions plus hydroxide ion, giving us 2 copper atoms plus 2 H2O liquid, O2 gas. That's the overall reaction in this electrolysis or in this electrolytic cell. So, to recap this lesson, we talked about conductors and insulators. We talked about electrolysis in general, the composition of an ionic or molten solution. In electrolysis, we talked about 3 major things. Actually, we talked about electrolysis of molten, ionic compound, like the lead bromide example here, PbBr2. We talked about electrolysis of concentrated ionic solution and diluted solution. And in diluted solution, it's also the same as electrolysis of water. The functions of electrolysis, I'll leave them to the next session. Thank you so much for watching. Don't forget to subscribe to the channel, like the video. If you have any question, leave them in the comment section below. The notes and classified are available on our Telegram group. You'll find the link to the group in the video description. Again, thank you for watching, and I'll see you in the next session. Take care.